Hello everyone, thank you for your gathering. I'm Takashi Menjo, researcher at NTT. Today I'd like to present Sheepdog, alternative software-defined storage on your OpenStack cloud. This is agenda. First, I'll talk about Sheepdog, including its performance and features. Then, I'll show how to integrate Sheepdog with OpenStack. So, what's Sheepdog? It's alternative open source distributed storage software. Sheepdog is fast and scalable, and hyper-converged implementation is possible. I think everyone here should know Ceph. Sheepdog can be an alternative to Ceph enough. Sheepdog was released in 2009 by NTT Laboratory. It was experimental at first, but now is on production use. Here are Sheepdog users. Worldwide, Alibaba, Taobao, Extensys, Ediworks, and so on use Sheepdog. In our corporate group, of course, NTT Data provides storage solutions using Sheepdog. Sheepdog makes storage cluster with commodity Linux servers. Then Sheepdog cluster integrates internal disks to storage pool and provides virtual volumes for KVM and iSCSI usage. Using this volume, we can use this volume for backend storage of IaaS, shared storage, and so on. I said that Sheepdog is fast, so I show you performance evaluation result. We compared Sheepdog and Ceph under even conditions. That is, same hardware and same replication configuration. We also evaluated scalability of Sheepdog and Ceph by increasing the number of storage hosts from 3 to 6. In detail, I show after conclusions appendix slide, so please see it later on YouTube. This is the result of IOPS performance of random 4K workload. Higher is faster, and gray bar is Ceph, and blue bar is Sheepdog. Two graph tells us that Sheepdog is faster than Ceph, and Sheepdog scales when the number of storage hosts increases. And then this is throughput performance of sequential 1024K workloads. This also tells Sheepdog is faster and scales. Sheepdog has several important features as storage systems. First, Sheepdog is durable. In other words, supports data redundancy. Your data is safe even if a server in cluster fails, because every volume is replicated across cluster. Second, Sheepdog is reliable. Sheepdog cluster remains running even if a server fails, because there is no single point of failure. Third, Sheepdog is manageable. When a server crashes, Sheepdog recovers data redundancy automatically, so it's easy to operate. Sheepdog also supports typical volume operations like snapshot, clone, rollback, and so on. Finally, Sheepdog is scalable, as you see in earlier slides. The more servers, the better performance you can get. Of course, you can integrate Sheepdog with OpenStack. We contribute Cinder and Grant's Sheepdog driver. You can create volumes and images on Sheepdog cluster. Cinder Sheepdog driver supports multi-backend, so you can manage multiple Sheepdog clusters for your own purposes. You can also share one cluster between Cinder and Grants. This improves image-to-volume operation performance. Okay, let's go to implementation. Using Sheepdog, we can build and expand our own cloud flexibly. And now I'm starting small OpenStack cloud using Sheepdog. Sheepdog requires 3 nodes at least. So I installed 1 OpenStack controller node and 2 compute nodes. Then I let Sheepdog daemon runs on each node to provide storage resources for users. This is minimum implementation. Happily, I win many users of my cloud, but they say they need more storage resources. So I want to extend my cloud. So let's scale out. I can get more performance and capacity by adding nodes that Sheep runs on. Hyper-converged implementation is possible, so I can scale both compute and storage resources by letting Sheep coexist on compute node. This can save my money for server equipment. I win more users, but they say I want not large capacity volumes, but high performance volumes. So implement multi-backend. I can provide high performance volumes by adding solid state drives on each node. As you see like this, you can expand your clouds as you need. So let's go to how to install Sheepdog to OpenStack node. First, install dependencies. We test Sheepdog on Ubuntu and CentOS. Sheepdog depends on some other packages, so install all of them. If you use CentOS, EPEL and Apache Bigtop repositories are required. For more information, please read install documents in Sheepdog repository or Turbo. Above all, in regard to QM, please use 250 or later because it contains important updates of Sheepdog driver. If you use CentOS 7.2, please build QM manually. And then deploy Sheepdog. Build and install Sheepdog by configure, make install, and run Sheep on each node. We want to run 2 Sheep on 1 node, having different listening port and internal disks, and belongs to different clusters. So please give invocation options like this to tell it to Sheep. Then configure Cinder backends. As mentioned earlier, Sheepdog Cinder driver supports multi-backend. One Sheepdog cluster corresponds to 1 Cinder backends. So in CinderConf, we can define Cinder backends like this. Here, please give the same Sheepdog store port as invocation option. Then configure grants backends. In grants API conf, we can define grants backend like this. Giving the same Sheepdog store port as Cinder backend, we can share 1 cluster between Cinder and grants. That's all about installation and configuration. And now you can enjoy Sheepdog on your OpenStack cloud. Let's go to conclusions. Sheepdog is alternative OSS distributed storage. It is fast and scalable, and hyper-converged implementation is possible. You can integrate Sheepdog with Cinder and grants. Finally, Sheepdog news and information. Sheepdog stable 1.0 branch is released. It's ready for production use and have new features. Our latest version B101 just has been released in this October. you can download Sheepdog from its repository. Pull requests and bug reports are very welcome. Here are mailing list for developers and users. This is the appendix of performance evaluation condition. That's all. Thank you very much.